Hi friends. Today we are going to discuss the second problem of Gauss Seidal method. For the system shown in the figure, determine the voltages at the end of the first iteration by Gauss Seidal method. Take alpha value as equal to 1 and the bus specifications are given in the table. Okay, in this particular problem they have already given the single line diagram joining the four buses, and the line admittances are also given in per unit. And they have also given a table which specifies which type of bus is given. And it is different from the previous problem because there is a generator bus in this particular problem. That is, a PV bus is present in this particular problem. So there is a slight difference from the previous problem. Okay, and the other two buses are the load buses itself. So how can we find the solution for this particular problem? Okay, and one thing also you have to note down, for the generator bus they have specified that the reactive power should be in this limit. Then only you can consider it as a generator bus. Okay, now let's go for the solution. What is the first step? First step is same as the in the previous problem. We have to first formulate the Y bus matrix. So Y bus matrix formulation is very easy. The diagonal values you have to do as taking the sum of the admittances reaching each first one. For example, each bus. For example, Y11, which means you have to take the sum of all the admittances reaching at the first bus. That means 1.2 minus J4 plus 1 minus J5. Okay, this is Y11. Similarly, you can find out Y22, Y33, Y44. Okay, the other admittances, that is Y12, Y13, etc. You have to take as negative value of the admittances joining 1 and 2. Example, Y12 is equal to, Y12 is actually 1 minus J5, but while you are finding this this matrix value, you have to take it as minus 1 plus J5. Okay, similarly you have formulate the Y bus matrix. Okay, so this is your first step. So by this we have completed doing the Y bus matrix. Now what is the second step? We have to set the initial values. So first we have to set the initial values for the load bus. V30, V40 is equal to 1 plus J0 per unit. It is a initial value which we are setting it. Okay, the next one is for the generator bus. For the generator bus, they have already given the magnitude of the voltage. The magnitude of the voltage should be 1.04. But they have not mentioned the voltage value, angle value, that is the phase angle. That we have to find out. Okay, we have to use the same given value, that is 1.04. And the angle is being assumed as 0. This is the angle is only the assumption here, not the magnitude. Okay, initially we assume the phase angle as 0 for the generator bus. Now next, for the initial setting for the slack bus. Slack bus we have already done in the previous problem, V10. The iteration values remains the same. So V10, V11, V21, etc. remains same, 1.06 plus J0 per unit. Okay, and for the slack bus all the iteration values remain same. Now third step, we are going to do the iteration. That is, we are going to set k is equal to 0, and we are going to do it for the first bus, second bus, third bus and fourth bus. Okay, and this is the general expression used for calculation. Set k is equal to 0 first, then set p is equal to 1. Okay, by setting the first bus, we know that it is a slack bus. So there is no need of doing any iterations. We directly get the answers as V11, V10 is same as V10 is equal to 1.06 plus J0. Why? Because it is a slack bus. There is no other change in the iterated values. Let's go for the next one, that is k is equal to 0 for the second bus. But here the second bus is not a load bus, it is a generator bus. So there is a difference in how to do it. Okay, first before doing the further for a generator bus we only need to find out what is the angle. Okay, before finding the angle, what we have to do is we have to confirm whether it is a generator bus or not. Okay, so the magnitude is already given. We only need to find out the phase angle, and for this we have to first confirm whether it is a generator bus. So first we have to how can we identify whether it is a generator bus or not? This is by looking at the reactive power constraint given. Okay, if the reactive power remains inside the range given in the question, then we can confirm that it is a generator bus. Otherwise, we will have to go for the next method. Okay, this is what is explained here. So to calculate the reactive power Q2, you have to use the expression -1 and -1 into imaginary part of this much. Okay, and by doing this, you will obtain, for example, we are taking for P is equal to 2, K is equal to 0, N is equal to 4, and we calculate the Q2 value using this expression. Okay, by finding the reactive value, we obtain the answer as 0.1456 per unit. Okay, Now we have to check whether it is within the limit given in the question. The limit given in the question is 0.1 to 1.0. It is given as 0.1 to 1.0. Why? Because it is mentioned in the question, the limit should be in between these two. So our answer obtained is 0.14, which means it is within the limit. So we can treat it as a generator bus. For generator bus, we only need to find out the phase angle of V21. So we are using the same expression as VPK plus 1. We are finding out the answer for this one. Okay, and we've obtained, at last we obtained the answer as 1.04 angle 2.05 degree per unit. Okay, and the angle is only needed. So we are taking delta 2 after the first iteration is equal to angle of this one, that is 2.05 degree. Okay, and now the value of V21 is equal to 1.04 is already given in the question as the magnitude. It is already given in the question. Okay, and the angle we are taking it as, which is obtained now, that is 1.04 angle 2.05 degree per unit. Is this clear? So let's go for the next step. What is the fifth step? The fifth step we are going to for setting the value of k as 1. K is equal to 0 for, what is the next one? P is equal to 3. So for P is equal to 3, we are using the same expression as in the previous problem. The same expression you have to use Vp k plus 1, and we are doing the same iteration, and we are obtaining as V31 and the value you are obtaining here. Okay. Now actually one step is there. What is that? We have to find the accelerated value. But in this particular problem, the acceleration value is given as alpha is equal to 1. Okay, while substituting this alpha is equal to 1, you will obtain that V31 accelerated value is same as the V31 value. So there is no need of doing the same step again. By substituting the alpha value as 1, you will obtain the same answer. Okay, let's go for the last step. That is sixth step. K is equal to 0 for P is equal to 4. By substituting it in the same expression, you will obtain this one. Okay, after the first iteration, you obtain the V4 value like this. Again, here also there is no need of any acceleration. Why? Because it is 1. Alpha value is 1. Now your results are obtained V11, V21, V31 and V41. But you have to note here that V11 is a slack bus. There is no change in the iterated value. V21 is a generator bus. What we did here is, first we confirmed that it is a generator bus by finding out the reactive power. When we confirmed it, we just found out what is the angle value. Okay, and this one is already specified in the question, magnitude. What about V3 and V4? It is done as the previous problem, that is, it is treated as a load bus. We completely done the iterated value of V3 and V4. We took both the magnitude and angle after the iteration. This is how you can to solve the problem if inside the given bus system there is a slack bus, there is a generator bus and there is a load bus. Okay, one more type of problem is there where the constraint is not it is not obeyed, or the reactive power, it is not within the limit. Then we will have to go for another way. So that we will be explaining in the, I will be explaining in the next class. Thank you for listening. Study well.